Okay, hello everybody. First of all, I would like to express my sincere appreciation to the management of the University of Ouezeva for inviting me for joining to this university. I am Dr. Ghanbari, Assistant Professor of Computer Science from Islamic Azad University, Ashtian Branch, Iran. I came here and joined to this university for different purposes. The first purpose is to teach some course in distributed system and sometime in blockchain technology. And also I have a plan to help the professors and lecturers in this university for preparing some grant proposal and something else, right? And also my second plan is to help the student to providing and completing their thesis, okay? The next thing that I will talk about is distributed system, which is very important and very interesting, right? Let me to explain something about distributed system, what the distributed system is, and why is distributed system important, and what is the philosophy of distributed system. In fact, talking about the distributed system is difficult, and there are no clear definition for the distributed system, and this technology maybe is technology, maybe it's science and something else, right? In fact, we are talking about a collection of autonomous computing elements that appear to its user as a single coherent system. Regarding to the single coherent system, the keyword here is the concurrency, right? We'll talk about the concurrency and the difference of concurrency and also parallel system. The distributed system is really act in between the user side and the system side. As you see here, there is a distributed system which include just 4 computer 1, 2, 3, and 4 computer 1. And we have also 3 different programs. Program 1 is run in computer 1, and program B is spread up across the computer 2 and 3, and also computer program C is run on computer 4, right? The keyword here is something like the middleware. The middleware hides everything, okay? The problem is that we have no kilowatt clock here. We have no something like shared memory here. It is very important things, and in this situation, we have to handle everything, okay? In this distributed system, we have a lot of challenge, for example, source synchronization, and also the time that every system are independent. Nobody have shared memory, and we do not have any clock, okay? Global clock, we must handle everything together, right? The main problem here is the difference of the distributed system and parallel system, which is important thing, and somebody confused about this. In fact, as you see in these 2 figures, in the right side we have a parallel system, and in the left side we have a distributed system, and in a parallel system actually we have a shared memory, which is very easy maybe to come to implementation sometime. And a distributed system in the left side is completely complicated, right? As you see, in a parallel system, we have a shared memory where we have not any shared memory, and the system must follow a coordinator for coordinating everything. For example, for sharing everything, to handling and managing the time, right? This is the list of some difference of distributed system and parallel system, which is clear. The first thing is that parallel system is tightly coupled. Memory is shared for all the processor, and this other side, the distributed system, refer to a loosely coupled, right? Meaning that the local memory we have here, and also in the parallel system we have a clock control, and it means SIMD and MIMD, and on the other hand, in the distributed system we do not have something like this, right? We have to synchronize, we have to handle the synchronization and also coordination, which is very important thing. During this course, we talk about completely and explain everything by detail, right? And the second difference between distributed system and high performance and parallel system is that in the distributed system, we have a large number of processors that can be usefully deployed. And a parallel system, we have a small number of processors that can be usefully deployed. And finally, we talk about focusing of parallel system and distributed system. In a parallel system, the focus of parallel system is a scientific computing and performance, right? But on the other side, this distributed system focus, the main focus is performance, reliability, availability, and something like this, right? Now let me to talk about the goal of distributed system. But the goal of distributed system, the four things is the main important thing related to this, the difference of, the goal of distributed system. The first is making resource accessible. This is a kind of ubiquity and availability. The system must be available every time, and the users must able to access to everything at the time that they want, right? Assume that this is a ubiquity and availability and something else, right? The second thing is openness. Means that everything must open and everybody can change, everybody can add or remove some document from this kind of system, right? The third thing is scalability. Means very important things and very challenge. We have a lot of trade-off here and need to discuss about this in great detail. We explain this course in these topics in maybe 3 or 4 hours, right? More than 3 hours, more than 3 or 4 hours, right? This is, we have also different types of scalability, a scale out, a scale with the keyboard is a scale out, and something else. We'll explain about this thing. We have different disciplines in scalability, regarding to scalability. The first thing is size scalability, and the second is geographical scalability and administrative scalability, which is explained in this during this course, right? And finally, we talk about transparency, which was the main and key element of distributed goals for a long time. there are a lot of, there are, that means at least 7 types of scalability, transparency, which is access transparency, location transparency, relocation transparency, replication transparency, and migration transparency, concurrency transparency, and failure transparency. The transparency hides everything from user side. Okay, for example, access transparency hides how to the element can be accessed. And location transparency means that the location of elements and the location of data will be hidden, and nobody know that the data, where the data is stored and where the data is accessing. Okay, and also the migration and relocation transparency, same thing. And finally, about the concurrency transparency means that the 2 elements want to access to the same data, and nobody know about that, right? And also this final thing is failure. Some system will be failure, and will be failed, and nobody understand what the problem is, right? And everything must be transparent from the user side. This is very important. And the main things and main reason for this distribution, for the transparency of distribution system, distributed system, is to have a secure system. Security is the main reason for having some transparency model. Okay. Now we talk about the architecture of distributed system, which is we have 2 types of architecture. The first is software architecture. In fact, we have to approach to the this problem. The first approach is a software approach. In the software approach, we have talk about the circumstance of some elements that work with together. This kind of software technology, software architecture, we do not pay attention to this. During this course, we talk about this thing, right? But the second type is the system architecture, which is very important. The system architecture talk about how the elements can be accessed and how the element can be stored, right? We have 2 types of the system architecture, which is client-server architecture and peer-to-peer architecture. As you see, pictures say, this picture show these things is this kind of architecture is something like client server. And in a client server, we have 2 different problems. The first problem is single point of failure, which is if we have a system between the clients, and every client can send some request, and the servers can send back response or reply this request. This is important, and if, for example, the server failed or crashed or some problem, the system the servers find some problem, the client cannot be active, and nobody can continue this function. Okay, this is problem. And also the second thing is having congestion. It means that a lot of people, a lot of nodes want to use some services, and it will be a bottleneck. Okay. This is also important. This kind of architecture for distributed system is not good. And the reality of the distributed system, in fact, lead us to have a peer-to-peer model, right? This is a architecture of peer-to-peer. We have a lot of system, a lot of connection. Each node can be a server or can be a client, right? If this is also is a this is a peer-to-peer model. This is a fully distributed system. Each node can be act as a server or can be act as a something like client. This is also explain the peer-to-peer, the kind of or classification of a peer-to-peer architecture. In this architecture, we have a peer-to-peer network which can be classified to a structured and unstructured peer-to-peer network. A structured peer-to-peer network is very easy, like this. This is a core model, which is explained in this course with details. And also, this one is a core model is in structured peer-to-peer, and we have also unstructured peer-to-peer. It can be centralized or decentralized or hybrid, right? Centralized, something like Napster distributed system, or decentralized can be like Nutella, and hybrid can be like Casa and Skype. Okay, this one is core. This one is Napster server, as you see in this figure. We have Napster server here. The Napster server is the red one is Napster server, and the green ones are the something like client. This is a music sharing. This system is for music sharing, and no music will be stored in the Napster server. Napster server is like just something like metadata, right? The Napster server is metadata. The address of and some thing about the music will be stored in the servers. Okay, the server can be act as a metadata server. Okay, and the data will be stored in the green nodes. Okay, and we also talk about this model in the future. Okay, and this one is Nutella system, which is very complicated, which it is also is Nutella system, and this one is hybrid. Okay, this if we have a lot of connection from the from a node to another node, it will be very complicated system. For this purpose, we have some node can be a super node, and the super node is the main connection will be between the super nodes. And if ordinary node want to connect with the other node, send message to the super node, and super node can connect with the other nodes, right? This is very easy and easy to control and easy to work, right? Okay, and finally, the problem is that what the distributed system and what the distributed computing. Okay, someone confused. Someone clearly do not know what the distributed computing is and what the distributed system is. Finally, we talk about the difference between distributed computing and distributed system. Everything that I talked about this is a distributed system. In fact, distributed system can be classified into 3 different types. The first is high performance distributed computing system, which is a type of this type mainly focus on computation. In this talk, we will focus on some type of distributed system that just talk about the computation, right? For example, cluster computing, grid computing, and cloud computing, fog computing, and so on, right? This one is a list of some distributed system that mainly talk about and mainly focus on computation. The second types, this is briefly called, this one briefly calls distributed computing. Distributed computing, okay? So distributed computing is a kind of distributed system that mainly talk about the computation, like fog computing, cloud computing, grid computing, and cluster computing. So the second types of distributed system is distributed information, just talk about the transaction and something else, and also the distributed system for pervasive, which talk about some thing like pervasive computing and ubiquitous computing, something like mobile computing and something else, okay? Our focus in this course is on the distributed computing system, which is just cloud, fog, and we introduced the cluster computing, mainly focus on Hadoop systems, which is a Hadoop cluster, or everything that is can be classified into the cluster computing. We talk about this kind of distributed system, right? Okay, if you have any question about this thing, you can be be free to ask some question about this thing. And we continue everything about distributed system in this course, right? Okay.